Hey, how's it going? Hey, B-Wag. All right. So today, I'm gonna be working on mostly bug resolution, answering questions. So thanks for hanging out. Hey, Loki Trickster. How you doing? Good evening. Hope all is well. There are some ridiculous bugs. I started to refactor my movement code because it was an absolute wreck. And it's getting better, but needs some fine tuning. So I ended up kind of factoring it as like a state machine in itself. It was just this big block of code like this, where there's a ton of if statements. Wanted to get away from that and all the while loops. I still have a lot of work to do on the jumping part. It works, it's okay. But like right now I'm not going into this last stretch, so I need to figure that out. Yeah, there's just a couple things I'm gonna work through. So that's what I'm doing today. Hey, look at that. That was good timing, B-Wag. Great timing is what it was. All right. So yeah, I think this is just gonna be a long session of changing a bunch of variables until things work. I think the logic is pretty good. There's a couple things that just aren't working quite right that we'll kind of work on ironing out, but other than that, it's not too bad a shape. So let me show you the first couple things. So one, here's kind of the running. Looks decent until the end. The end they just stop. I have a state. You can see in the bottom what state I'm in. State 6 is the stop state. State 1 is the run state. There's a state in between there that should occur, and it's the run to stop state. So it's not going into that for some reason. Got to think through that. And then something else that's kind of weird. I guess jumping's not too bad right now. It's not great. There's a little bit of flailing involved, but ultimately not too bad. And other than that, I'll show you the enemy. The enemy is all sorts of messed up. You might have seen kind of in the intro, the enemy kind of running all over the place. And then also the other guy, for some reason, right next to the wall. So you see that? That's not supposed to happen. She gets there eventually, but yeah, it's not what's supposed to happen. So I got to think about why that's the case. Everything should be, there we go. Okay, I think, so I got to kind of work through that. I think what's kind of happening is overcorrection. This looks like a undampened spring, right? So if you imagine this is a spring, this is an undampened system. So I may need to like develop some sort of like PID control, or if not PID control, if I want something just simple, because it's not, everything's very predictable, which makes this a lot easier. But I need a better control system, because obviously that's not gonna do it. So that's what we're gonna be working on, kind of resolving those bugs. And it's all within these like 5 lines of code here. So yeah, if you have questions, feel free to ask them. In the meantime, we'll just kind of be chatting. I'll talk through my process as I'm kind of working through this. Okay. Excuse me. So the first thing is that there's obviously an issue. I am getting into running, which is the correct state here. So I don't think any issue up here at the moment. It's undamped here, which is kind of the problem. So I have a function that essentially takes this node. Now this is looking forward in the same direction I should be running, which should always be straight. Oh, do I really? Oh, weird. Thank you. I don't even know why that's a tab that I have. I appreciate it. Thanks for letting me know. All right, now you can see the stream tab and know what's happening in the background. That's a look behind the curtain. So yeah, let's see. So the big thing is setting my velocity here. These are a pretty simple function. All this does is it sets the X and the Z direction, ignores the Y direction. and it uses this move toward function. The move toward function, what it does is it essentially takes a variable and it changes it by a set amount, and it sets a target. And I've got that target clamped to essentially change the distance. So if I had like if I set something forward, like for example, if I was 100 yards away from it, right, it's not going to run off and I'm not going to get super speed. It essentially sets the speed to something manageable. So yeah, so I have that set like this, and I have it multiplied by speed so I can control how fast they go, but it's a little bit undamped, which probably means I'm running a little bit too fast, or I'm not accelerating fast enough. So for example, if you think of this like a spring, the acceleration would be your damper, right? Your movement speed is essentially your input force. So I need to damp that input force. So I need to raise up my acceleration. I think it's just going to be, I may have to make this a variable and kind of tweak it. I think it's going to be just a lot of tweaking, because too much, the problem is too much and you won't have good, like, reasonable motion, right? It's going to look a little bit unreasonable. And I do think you can probably stop faster than you can start. So I may have to have 2 accelerations. So you can see how fast we stop there. Also don't know if I'm actually directly in the middle, so I gotta look like this. Yeah, she stopped directly in the middle, but you can see she kind of started and stopped very fast. The starting it really isn't too bad. I gotta decide what I mean, she just takes off, right? Yeah, I want a little slower start than that. So, let me check. Let me do this. I'm gonna go ahead and export this variable, just to let me control it. I see. Okay, yeah. Let me walk through that. That's a good question. Let me set this real quick. All right, and I'll just make this a float. All right. And then I also want to set it equal to 1, actually. Do I want to set it equals 1? Can I do that? Okay, so yeah, let me walk through what some of these things mean. So yeah, vector 2 and a vector 3, all the vectors are, this is just like a 3-dimensional vector. It's a like a so a point from the origin connecting, right? If you're familiar with like vector math, all it is like you have your grid, right? We're PowerPointing it. So yeah, you've got like a 2-dimensional grid, right? There's 1, there's 2, right? Based on some point in space, right? Like let's say there's just a point out there somewhere. I can create a line from the origin to that point, right? That's a vector. Okay, this right here in green, that's the vector. So if I do this in 3 dimensions, for example, all you do is you point towards like a space in 3 dimensions. So it's just like a variable type, right? So now this is my 3-dimensional vector that I can put anywhere in this screen. So the way you use that here is it stores an X, Y, and Z direction. And so if I call like velocity, that's a velocity in 3 directions towards that vector. So I can go like say, hey, in the Y direction, that's if you look in Godot, Y is up, right? So that's a vector direction of 1. Or I guess 0, 1, 0, if that makes sense. So you're essentially just playing with 3D space. Vector math definitely helps. So if you've taken like any kind of trigonometry or trying to think, I guess you don't really use like matrices, so it wouldn't be like discrete math or anything. I think mostly like trig or calculus probably use quite a few vectors. Yeah, you wouldn't really call vector, you probably wouldn't call like a vector 1. There's not like a vector 1 type. There's only a vector 2 and a vector 3 type, because like 1 is just a dot on a line, so it's just a length. So vector 1 would just be a length. Vector 2 has an X and a Y component up to algebra 2. Got it. Okay. So yeah, if you think like a triangle, right? If you know Pythagorean's theorem, right? you have x squared plus y squared equals c squared. So if you take the length of a vector, you always get that c squared. So that's essentially what you're looking at. Okay, yeah. So you're always, you can do really useful stuff with it because you can get like the length and stuff, and you can store three-dimensional points in space. That's where like velocity, that's just pointing where the velocity is just, speed with the direction. So all it is speed times a vector. Even in like, physics, right? Velocity, just speed times some vector. And so we're just taking that vector and manipulating it. But it's just a data type. This should allow me to change it. The vectors, the length of the vector, this part here, that green part is always the hypotenuse, correct? Yep. And then the if you take on this, right, and you take like if you take like down, oops, right? So like here, if I go down with this to like say here, this point is if I have this direction and towards you is like the x direction. Where that point meets this line, it's there. That right there is the x value. And then this right here is the z value, or I guess the y value in Godot. And then where it meets this line back here is that would be the z value, if that makes sense. So that's z, that's x, that's y, and together they form this vector. Let's see where we're at. Okay, so now I'm just stopping. I think my acceleration's a little too high. Oh yeah, I was gonna see how squirrely okay, very sharp. So now it's what we'd call an overdamped system, right? If you had a spring that behaved like that, like a pendulum that behaved like that, you might actually, you know what? There's still a little bit of overshoot. So it's still underdamped. What I want is no overshoot. So I probably do need PID controller. So PID is proportional integral derivative. So what I need to be doing is calculating a PID space, because the problem is when I'm going to change directions like this, my character's not anticipating it. They're blindly running, right? And they're overshooting because of it. And the overshooting would be okay, except it's really hard to control this. So what I need to be doing is looking at, or at least maybe a PID controller. Like I should use speed. Well, yeah, so I'll use my speed, I'll use my location, and I'll use my acceleration, essentially, by change in velocity. So all I really need to do, I think, is look ahead. Graphics such as demos. I'm not sure what you mean there. Oh, graphing? For graphing? Yeah. I mean, if you're using like you're graphing something, then absolutely tons of vectors. Vector math's honestly really useful. Vector math is probably one of the more useful maths. So I think I've mentioned before, I work in space applications. We have a mission coming up actually, and of course, when you're dealing with orbital mechanics, everything's vector math. Oh, Desmos is a graphing calculator website. Okay. Very, very possible, right? So graphing calculators, they likely store all their variables as some sort of vector. Yeah, because it's just a position in space. With a vector, you can map any location in 3D space. Let's see. And it's just a pointer from origin to where it's at. Okay, so I'm going to, real quick, I've got to refactor my code a little bit. So instead of this, I really need to pass the whole array in. And then I think I'm going to have to calculate like I think I'm kind of going to have to create like a PID on this, which is going to be a little bit complicated, but it's going to simplify the code up here. I kind of tried doing something like that here where it's kind of looking ahead. I think the problem is that like for turns, it's not smart enough. So I really want to keep this simple. Movement nodes. So I'm going to simplify this a little bit. I think that probably means, well, I'll keep the last stretch for now. So movement nodes, movement speed, acceleration. Down here, I essentially need to calculate variable p equals, this is going to be, we'll just call this my speed. We're going to have variable kp equals proportional, we'll call it this is proportional gain, so we'll just put like 0.1 for now. Variable I equals, we'll do, I equals integral, let's see, well, really I guess I don't need variable I, because we're gonna use we do need gain, we do need variable ki. And all I'm doing right here is going to set up a PID controller. I think that's probably the best way to do this. 0.1 for now. What I'll do is set these at the top. So what this formula is going to look like, I'll say like PID control equals, we'll have like KP times position, I think. Let's see. Yep. Vector 2, 1, 1 would just be the coordinate 1, 1. Absolutely. Depending. I mean, if it was, as long as your origin's 0. So origin matters too, because like the vector coming out of my character is, the origin's 0 for my character locally, not globally. Yeah, sorry if I was overcomplicating that. Wasn't trying to. All right. So this is going to be, this right here, the KP is just the distance between where I want to be and where I'm going. This is the error value. So times, we're just going to actually call it error. Variable error equals that. So that's essentially capturing how far I am away from my target, right? So I have my movement target, and I think I can probably do this in 3D space. Do I need to do it? Let me think. Yeah, I can probably do it in 3D space. So I'm going to see how that's .x. I'm going to get rid of that. So now I'm working in vector 3s, which might make this a little more complicated. We'll see. So KP times error plus, and we'll have KI. I need the derivative of error. So I'll say variable dt error. This is how error is changing over time. So what I need to do is I need to have last error up here. Variable last error, and then we'll just keep it 0 for now. And then what I'll do is I will say at the end of this, I'll calculate my last error. dt error equals this. I guess it equals error. Okay. Then so I'd multiply this by dt error. That's going to account for how fast it's changing over time. All right. Let's see, plus, and we'll do variable. Plus, and then what we'll do is the change. So we're going to do KP, which is proportional gain, I guess, here again. And then we're going to do the change in error over change in time. So let me see how we would implement that. Okay. So really this is the change in, this is really dt times dt error divided by, let's see, change in time is always gonna be the same. So really I think we can just do times dt error here. And then this should be the integral. So this is how much that error has changed within the last time segment. It's hard here because, well, it shouldn't be hard here. I mean, it should be exactly the same here. Let me pull this up. It's been a long time since I've messed with control systems. Let's see. Okay. All right. So they're using something called a Laplace transform, which you do a lot of in calculus. discrete math to essentially change the, you're essentially changing the, it's been so long since I've done this. You're changing the domain of the thing from, it allows a lot of, you go into the time domain essentially, which allows for easier thing, right? Because we're talking about here this. I wonder if Godot has a Laplace function. Let me see. Let's see if they have a Laplace transform. I don't believe they do. I'm sure we could figure it out, but we're going to keep this a little bit simple. So the way I'm going to keep this simple, I'm going to, instead of multiplying this out like this, I can probably just account for speed, right? So if you think about this, right, change in error over change in time is really just change in speed. So I'm going to do dt speed here, and that should give me that. Let's do that. All right, so let me go create a variable called dt speed, or variable last speed. Oh, I called it last speed. Let me call these, I guess that's fine, last speed. So variable last error is what we'll call it here. Last error equals error. We'll call this last error. And then for this, we're going to do the change. Let's see here. What do I want to do here? So I need dt error to be, I do need dt error. I need dt error to be last error minus error, right? So it's the change in error. It is really the change in error over time, but I think we can ignore the change in time for the most part here. So, okay. We'll see that. So I'm gonna have to think through this too, and I'm gonna have to be changing these. So what I probably need to do is take these up top. Let's see. And variable these, and then the thing with PIDs is you have to tune them. That's what these are. These are tunable parameters, so that I can modify them. So export this, and then these can be floats. All right, that's gonna let me tune those. And then so what I'll do is variable p speed last speed equals speed, and then what we're gonna have is this is gonna be just the speed. Speed. Okay. What doesn't it like? Okay, well, it doesn't like it because there's already a speed on here, which comes from this, which is really my max speed. So I'll change this to current speed. And current speed, all current speed is going to be my velocity. So I can say, actually, I guess I could do that. Yeah, let's do this. Variable speed, current speed equals character dot velocity. Okay, last speed equals current speed. Right, so every time it does it, it changes. Oh, there's already a current. Okay, I see. Yeah. So current speed equals velocity. We'll call this again PID or control. Variable control equals. Okay, so now let's walk through this just to make sure I'm getting this right. So I'm using my speed here just to actually calculate how fast I'm going to move, so I can pull that out. I don't need it right now, but essentially I have my error, which is going to be my distance to the target. I have my change in error, which is my last error minus my current error. I have my current speed, which is my character velocity. I actually want to change this, and I want to do absolute value of character velocity. The reason I want to do that, and I probably want to do vector 3. The reason I want to do that is because velocity has an implied distance, right? And I want to take that out of it. I don't want my current speed here to have anything to do with that. Actually, you know what I can actually do is dot length, right? We talked about length of vectors, so it allows me to actually just take the length of it, and it's going to figure out how long that vector is. Okay, so current speed. So then what I'm missing, I think, here, so I have kp times the error, that's good, plus, and then I have ki times the delta error. Do I want to do delta error? This is how much ground has been covered in the last thing. It's really how much error has been corrected. I think that's okay. And then it'll be kp times, I guess this is ki, times kp times the change in error over change in time, which is speed. So then we would do, I need a dt speed. dt speed equals current speed minus, I guess last speed minus current speed. Minus current speed. Okay, now here's the problem. When I run this, it's going to look absolutely wild. And the chances of my PID controller working perfectly the first time is very low. But then we can tune it up and see if we can get it done. So I'm going to clamp this. I do want X and Y or X and Z values, I think. I don't think I need move toward. Do I need move toward? Because I'm already dampening it with this PID controller. I guess I probably do. So instead of this, I'm going to set the velocity equal to we'll use speed this time. So I'm going to set the velocity equal to control dot X, and it's going to be negative speed to speed. That's essentially clamping it where it doesn't go above or below speed. And then I'm going to do the same thing here. I'm going to say control dot Y, clamp control dot Y, negative speed. Okay, and it looks like this is super complicated, or control Z, sorry. It looks like this is super complicated. The reason I'm doing this is, again, I want my character to dampen itself as it goes along. Oh man, the only issue is I'm not going to be looking ahead in this way to the next square. So I imagine they're actually going to stop on the square. And so I've got to think that one through. Because like right now, if I was going to run this, which I guess I can, what's going to happen is, which I haven't tested this in a little bit, we'll see if it still works. What's going to happen is they're going to stop on every square. But they might stop it on it pretty efficiently. We'll see. We'll just test it out, see what happens. I think my prediction is that I'm going to run really slow. It will probably hit the squares, but I'm going to run very slowly. Oh, it broke. 1 second. Oh, I'm subtracting an array. Oops. And a vector 3 here. Oh, movement target. Okay. 0, that's why. Okay, easy enough. All right, let's see what happens here. Okay. Oh man, a little bit of mess up here. Okay, so I have an int and a vector 3. Oh, it's because when I defined this, I didn't create this top as a vector 3 first. I need to do that for error and speed. They both need to be vector 3s. Vector 3, 0, 0, 0. And vector 3, 0, 0, 0. We're close. All right. Let's see. This is like the first bit of actual math I've had to do on this game. Besides, I think navigation, which is related. Okay, here we go. Okay. What we got? and float in DT speed. Typings are killing me. Let's see. So last speed minus current speed. Oh, it's because... Oh, okay, I see. So last speed actually is a float because I'm taking the length. So 0.0. Okay. Last speed equals current speed. That makes sense. Except... Okay, you know what? I do need this to be... I probably just need to use velocity. And it may be okay, actually. Let me think here. I wonder if I can take the absolute value of a I'm at a loss for words, of a vector and get all positive values. Probably not, but maybe it's okay. Let's keep it velocity because I'm just multiplying the control. So I actually do need to keep signs in there because I need this to be a negative value or a positive value depending on where I'm going. So that probably is good. Okay, yep. This one though, because I'm adding in the air, we'll see. Again, I'm gonna have to do some tuning. We'll see what happens. All right. All right, so I'm running. Let's see, is she actually moving? Nope, let's do some tuning here. All right, so let's see, I'm gonna pull that up over here and I'm going to go into this. Let's see, it's my movement node. Okay, so 0.1. We'll start with somewhere around there. I don't know what this is gonna end up being. Let's check. All right, so let me try to move here. So now I'm moving about that speed. And I imagine they're going to, okay, so we need to undampen this a little bit. Let's just start with ones here. This may be actually pretty forgiving. With how little that changed on a 0.1, we may have a pretty forgiving system. Oh, I didn't have to change that, oops. So that's pretty good. If we have a forgiving system, this may go pretty quick getting this tuned, which would be good. And then I will set it as a constant because I want it to be the same for all the characters. And I don't want to have to go set them all independently. So, all right, let's see what we got. All right, it didn't like going to multiple here. What we got? So I ended up with a float on the second run. Let's see. So I had a float and a vector 3. This was a float. Movement target. Why was that a float? Oh, you know what? I think I might know why it's a float. Let's see. Let me find right here. That's why it's a float. Let's see if there's any other of those. Velocity, XY. Nope, the rest are good. Okay, perfect. Let's try it again. So I think I'm gonna have to have something much higher than 1, which again is fine. The fact that I'm able to control it with pretty large numbers means the system's probably not too sensitive, which is good. You know, I just realized I could have done this a whole lot easier. One moment. Okay. Let's see. We'll do this here in a second. I think I can actually just use my acceleration and set it, and make this a lot simpler rather than using this whole equation because I'm in a game engine, right? I'm not having to do everything based on positions, which is what I'm doing right now. So what I probably need to do here is I need to have DT error. I need to have dt speed, which is the acceleration. And then I need to have variable. I already have the acceleration. Then what I can probably do, so this is the change in error. This is the change in speed. Let's see. I think here acceleration is the integral, or is the derivative of velocity. Is that right? Let's confirm. So yeah, acceleration is the derivative of velocity. So if that's the derivative of velocity here, then I think I can just use Excel for this. Excel. That's how fast it's changing over time, which is my dt speed. You know, I'm gonna leave it. Okay. The only reason I'm gonna leave it is because I'm basically doing the same thing except okay, yeah, let me use Excel on this. And I can get rid of dt speed. It doesn't change a whole lot, except it does eliminate a variable. But that's fine. That's just a little bit easier. Okay, let's go back to tuning. Let's see. All right. Cool. So let's see. First, we know that, oh my goodness. Okay. Okay. We know that 1 was too small. So let's change this real quick to 10. Oh my goodness. When I tried messing with my controller and my mouse at the same time, it doesn't like it. Let's change this 10. All right. Ooh, attempt to call move path. A null instance on a null instance. Where's that at? Up here? Very interesting. Oh, look at that. I moved the node. Huh. Okay. Well, that's okay. I don't know why I did that. That was an accident, but it's fine. Okay, let's try again. I might set up right now I have like KP, like proportional gain. I need to really set that up as its own independent gain. So I should have a KP, a KI, and a KD. I think that level of control is probably a little better here. Once I get all the things set, because obviously, okay, I see what's going on now. I probably will calculate DT speed. It's because I'm using it as a float. That's all right. Okay, so let's go ahead and calculate DT speed. Okay. And actually, I could probably set this to... No. I cannot and should not set that to Excel. They should end up being Excel. I'd be surprised if they're not. I'm going to go ahead and change this to KD. And I'm going to have a derivative gain. Export variable KD float. That's going to let me tune it a little bit better. Let's try that. Okay. Very good. Okay, so you see how she runs? That's actually not too bad, but you see how she runs to each square? That's because I'm not looking ahead. But honestly, that's not terrible. It's just I need to not be looking at I need to be looking forward. Hey, White Boss Gamer, how's it going? Good to see you. We are tuning a PID controller and working on resolving some bugs here. I refactored a lot of the code here. Okay, so I think all I really need to do is if there is a movement 1 to look forward. I'm doing pretty good. How are you doing? Well, for me it's evening, for you it's morning. Let's see. So essentially I think I want, on the error side of this, I want essentially, well, I think I just want like an extra push, right? Let's see, if there is, I gotta think this through. I think if there's something up in front of it, right? So I can say if movement target dot size is greater than 1. So if there's something in front of it, I probably should just go ahead and set the character velocity to be something consistent. Yeah. So what I can do, I think, is just, if it's 1, instead of having a control on it, I don't have to be as tight. This could just be error times speed. So essentially it's direct. So I don't need a PID if I'm not changing direction. Except I do if I'm changing. Well, maybe not. Let's see. Let's do. So it's just gonna be error times speed. Okay. So that's just gonna be error times speed. Or I guess it'll be error.z times speed, and this will be the error.x times speed. Otherwise do this other thing. Okay. Is that right? Do I only need the PID controller if it's not quite right? I may have to look forward to that square. And if that square is on the same direction I'm running, go ahead and run full speed. Otherwise, start working on changing directions. I've got to think about how, let's see, I'm okay turning 2 within the box, which would let me just look at the next box and turn. I don't think I need to turn that sharp of corners as long as I stay in each square. So maybe that's the... Okay, now it's way worse. Oh man, she's freaking out. What happened? Okay. I think what was happening there, she got to the last one. So yeah, I think really I should be doing the same thing, control, but just looking ahead. So ultimately, yeah, then that would mean these are the same. I would basically just modify my control a little bit. What I can probably do then is my DT error. I could change, if there's something ahead of it, go ahead and look at the one in front of it and use that as my DT error. Otherwise, now there's maybe a huge mistake, but we'll see. Else, so that's gonna be, let's do this. So we'll have DT error, and then we'll have DT error is this, except, I guess it's really the error I need to change, not DT error, huh? Well, I guess I can keep that. And then this would come down, and then I can have error definition, and I could say error equals this. Error equals this. Okay. And then here I would just do 1. If it's bigger. Look at the next one if it's bigger. Otherwise, okay. That, it may be okay. I'm trying to get to a point where I can tune it. I'm trying to think here. If I lower the KP, then this might work because it'd be more focused on the speed I'm moving. Let's see what happens here. Okay, that wasn't too terrible. Let's see what happens when I turn. Oh no, turning's really bad. But, you know, she's getting there. Sort of. She's off by a whole... Look, she's going back. Okay. So turning obviously is bad. Oh, man, everything's bad. I don't know where she's going. We lost her. I think I need to reset the values. For like last error and current error. So let me think through that real quick. Yeah, I mean, well, I guess ultimately just reduce these, right? Let's keep KP at 10 and reduce the integral and derivative inputs. And that should make it matter less about what my previous error and speed were. And like I said, I might have to go look. I was trying to make the equation as complicated as possible to keep the logic as simple as possible. If that makes sense. I was just kind of trying to not have to calculate. Okay, she thinks she's getting... Okay. Well, she got there. What if we turn here? Okay. She needs smoothed out a little bit, but... Okay. So, let's see. What was changing on her so much? I gotta think through this. I mean, she's obviously freaking out here. This is the worst. Okay, she's changing animations a lot. Man, I broke this. Let's see here. Let me think. Let's see. So she's kind of going all over the place. I mean, if this is 0, it works. I just got to think about how to look ahead. That way I'm not stopping every time. And I guess I could just add, if there's more than one, just add some direction to control. That could work. I may be overcomplicating this a little bit, but like that works decently, right? I mean, obviously it's very clunky, but it's tightly controlled. So oh, she didn't like that. Okay. All right, so let's see here. I think what I want to do, what if I do turn this down? I want to see where that jittering's coming from. Let's see if I turn like these down to 0, if she still jitters. Okay, it does get the jittering out. What if I turn derivative up to 1? Okay. There's definitely jitter in there. What about the integral here? Okay, so no derivative, no jittering there, it looks like. Okay, so that's helpful. And then what I think I can do is go change this to look forward to 1. I think looking forward to 1 is good. Kind of thinking the integral either needs to be really small or non-existent, which is fine. Based on this, I do think looking forward would be good. Let's see what happens here. Well, see, that's one of the issues, right? I mean, that works. That looks pretty decent. The issue is like she's gonna run in a diagonal. Okay, so this is where it's really gonna help to have a PID controller. I need her not to change her. I need to essentially add some resistance to changing direction, which I can do by looking at, let's see. So resistance to change in direction is going to be resistance to acceleration, I guess. Let me think. So this is where I think I could add this at least a little bit. Nope, didn't change much there. Okay. What if I did make this a 1? It's probably just such a small parameter. I may have to turn the other ones down. Okay, that does not change that at all. Maybe if I turn this up. Okay. Turn the change in error down. Okay, so she's still beelining there. Let's see if I can figure out which of these parameters. Let's just set this to like 5 right now. One of these parameters should force me to try to stay in the same direction. Obviously I need KP to be a lot bigger than the other ones. Okay. Let's see. I think I need KD to be a lot smaller. I mean, that works, except I don't want to run at an angle like that because there's going to be times when, like, I do want to run kind of at an angle, but I wanted to run more like an arc. Oh, that was way off. What happened there? That's very interesting. Very, very interesting. So she obviously didn't make it to the final target there. Huh. So is my... Let's see, even if like this, she should hit the final target. But she's not. She's getting there and then stopping. Why would that be? Let's look at the code real quick. So if movement size is greater than 1, do this, otherwise do this. I'm getting to essentially the last target. And then stopping. Let me print error here. Print error. And then let me turn off printing the current state, which is in movement actually. Let's see what happens here. All right. Okay, that makes sense. Okay, so you see I still have a pretty large error. Oh, my error is now very small. What happened there? I'm not actually getting any closer, right? Okay, I'm 100% looking at the wrong node, and it's possible that I'm not. You know what? Because I'm going at an angle, I'm never getting to every node. And the way I have this programmed, I have to touch every node. It's like you're playing baseball, right? So if I don't touch every node, I won't actually complete the home run, to stick with my sports analogy. Okay, so yeah, that's the problem there, is I'm not hitting every node. So where it thinks it is and where it needs to be is way off. But it can't get there because I'm looking at the one forward. So it actually gets to the right square. It just stops. Okay, so I have to do this a little bit smarter. Okay, so ultimately, yeah, my error has to stay the same. My error has to be this. But I think what I can do is just, let's see. So my error is gonna be the same. Let's go ahead and put that out here. Maybe I can just add the vector for the DT or the next target. So maybe I have a variable and I say next target. And I guess I could do that only if the size is greater than 1. I'm essentially saying, hey, if there's more than one node in this array of nodes for my positions. So I can say next target equals movement target 1 minus character dot position. So that's probably a better thing to track like than my change in speed. So I can say next target error. And I think I can put that in my control node. What would I replace with it? Do I like my change in speed? Or do I like my change in error better? Probably change in error. I don't think change in speed is really doing a lot right now. Oh, character dot position divided by world grid map size. Okay, I feel a little better about this actually. Instead of viewing DT speed, I'm gonna do next target error, and that's gonna let me control that. Oh, I guess I need a variable. Variable next target error equals 0. And then here I can say next target area equals that. If it's more than 1. That will actually help because then I can kind of tune in how much of the next target I'm looking up to. That's interesting. That may be a better control system. Let's see what we got. Okay, first off, I've got only proportional gain. Let's see how that one works. Okay, kind of how expected. Oh, it broke. Let's see what it didn't like. Vector 3. Let's see. Is next target error? This would not be a vector 3. Interesting. Oh, I see. Vector 3, 0, 0, 0. There you go. All right, let's give that a shot. Okay. All right, kind of what I expected here. So let's cancel that. Now let's go ahead and add in this looking forward. I'll just make it a 1 for now. Make sure that saves here. Okay. Okay, so one thing I have to change, I probably want to go ahead and add as a variable is my kind of tolerance here, movement tolerance. So essentially, right now I'm saying like, hey, I have to be within 0.05 meters of the center of the square. Probably need to be a little higher than that, at least to take credit. The problem is when I do that, I won't end up in the center of the squares, which may be okay. Like as long as they're in the square, I think it's really fine. Okay. All right, so now I can turn my movement tolerance up to like 0.1, maybe 0.2. Oops. There you go. So that's her move at least. Okay, so let me turn up the derivative gain here. Turn on my movement tolerance to like 0.3. Okay, I still need derivative gain up a little further. Starting to get there. What if I throw in some integral gain? There you go. This is the power of a PID controller. Okay, that looked pretty smooth, except the animation was way bad. But I think I know what's going on there. Other than that, though, I think it looked pretty smooth. Let me turn off that animation real quick. Let's see. That's gonna be this last stretch. Just go ahead and turn that whole bit of code off. I'll have to program in the last stretch. It really needs to be only on the last one. I don't know why that's weird. It shouldn't have been running that much. That's really weird, actually. All right. Okay, a little teleportation there. Okay, that's really choppy. I'm gonna turn this up to like 10. Okay, that helps a lot. I need to turn the movement tolerance down. You can see her doing the jump, like the teleporting at the end. I don't want her teleporting. Okay. Change this down to like 0.1. Okay. So she is looking. Let's see what happened there. So she's not getting to the middle. Okay. So 0.2 maybe. Okay, but she's like accelerating. She's not running smoothly through there. So maybe I increase my error, my integral. Which does help me run a little smoother. Is she choppy? It's hard to tell. She's still teleporting at the end. I really want her to not teleport, but for her not teleport, I think I'd have to go like 1. You know what? Let's not worry about setting her. Okay, so I have this little bit of code in here. It's kind of like my failsafe. It's to say, hey, at the end, go ahead and teleport to the right spot. Maybe I just go ahead and get rid of that because I really don't think it helps that much. That's right here. All it's doing right now is making everything look choppy, but I think as long as my PID is right, then no matter what gets thrown at me, if I have some kind of outside force, anything, I should get to the right location. We'll see what happens. And yes, things like this, like a PID controller, this is what they're using on pretty much every control system you can imagine for gain control. And you can see why it's powerful, right? At first we started a little bit sloppy and it was kind of difficult, but what it really provides is the ability to tune it, right? And tuning is so important to get things looking clean. Am I running to the right square? Yeah. Yeah, but I'm gonna change this movement tolerance to 0.05. Essentially, I just want it to be a lot more tolerant, or a lot tighter. Okay, you can see I'm kind of going and stopping in the middle now. So this is where I can turn this KD up a little bit. Yep, you can see it's a lot smoother. And then she slows down at the end pretty decently. Okay, let's see a turn. Ooh, she got knocked out of the way. Okay, so there, she is not quite getting in the middle. So what I should do here is I need to turn probably down the proportional gain. Well, actually, no, I need to turn down the look ahead gain, which is this, which we just turned up. That's okay. Let's see. All right. If I really want to be within 0.05, I really need a pretty tight gain here. Oh, well, 0.05, I'm going to get there for sure, but it's going to be real rough. Let's see. You know, I could set that dynamically too based on where I'm at, which maybe wouldn't be too bad. So essentially, if I'm turning, the movement tolerance goes up. Let me think about that real quick. So I could, yeah, let's do that. Let's say, so movement tolerance. So let's not export it. Maybe I can export it because I think that'll let me control it. Let's say if target size is greater than 1, movement tolerance equals 1. Maybe not 1, maybe like 0.5. Let's see if this updates. I don't know if this will update live on the screen. It might. Otherwise, I can go to the remote node here. Let's see. Okay. So you can see she's stopping right on the edge because I didn't set the opposite. I need the opposite to be true. If the else, what I want to do is I want to say movement tolerance equals, and then have some min tolerance. And then this can be max tolerance. And we'll export those instead. That way I can control things. It's really nice being able to control things in the window. So then what we'll have is variable tolerance, float, export, variable min tolerance, float, export, variable max tolerance, float, and then we could say equals 0.05, and then this equals 0.5 is what we'll start with. Okay. What I'm hoping for is that she'll kind of round the corner and look just a little more smooth and a little more natural. Not bad. Okay. She does turn really fast. So I think what I would do, let me think real quick. I think what I would, let's turn down proportional gain here a little bit. Okay, nope, I need that to stay high. To slow her down a little bit, let me think real quick. She's a little bit squirrely, which the squirreliness maybe isn't that bad. Let me see, so KI is the change in error. So as I'm getting closer, you know, this piece might not even matter. Yeah, I don't think that's actually contributing much at all. I guess it's telling me if I'm getting closer to my target, but ultimately I don't think it's doing much. Let's see if I set this to like something crazy like 100. Well, I think I'm just clamping out speed at that point. Okay. Kind of, I mean, it does help me track a little better. Let's set this to 10. So I think that's where I will start cutting corners. Okay, so this, I need this to stay a little lower. I need this to probably go down to like 2. I just need her to be a little less squirrely. Okay, that's not terrible. Just turn the corner really fast. I wonder if I turn this down, if she'll turn the corner a little slower. Let me think. I guess I could turn my max tolerance down to like 0.2, and she should turn the corner just a little bit slower. Well, she like slows down and then speeds back up. Oh, that's where my proportional gain would help. Okay. I think that's okay because I can look ahead here. I guess this one's actually the look ahead, huh? I think I was basically just maxing out speed all the time. Ooh, that didn't ever get there. Which I guess is okay because I can just increase this. Let's see. Is she still teleporting or is she actually running? She's running. I'm turning the corner a little too much. Is that where this will help? Yeah, that does make it a little bit smoother. But yeah, it's kind of the last second that she turns the corner. And then she's just like there. See, she's kind of like bouncing. How's she do on jumps? She doesn't do the jump animation, that's for sure. Okay, let's turn my KP down. Okay, I need KP high enough that, let's see. Let's tune this methodically. First off, I need to be running fast enough initially. Okay, maybe like a 3. Okay. Then what I need to do is I need to say, okay, so now that I'm running fast enough, how fast am I approaching my target? Let's leave that out for now. And then the other thing I need to do, and that actually may need to turn into a subtraction. I may be better off subtracting that than adding it. We'll see. So basically, I'd be slowing myself down as I approach my target. Okay, so now let's add in like a 1 here. So I look ahead. Okay, it's too significant. So I can raise this. I'm going to end up with the same tuning. Okay. What if I do add in this change in error here? Does that round the corner? It does not round the corner. Okay, I probably have to turn my max tolerance down. Yeah. I think 0.2 is a good number. That's basically how close I have to get to the center of the square. Okay, that looks pretty decent. Okay. That's not bad. A little bit choppy, maybe. So the choppiness I can get out by turning this up. Nope. Maybe like a 1.5 here. Okay, not bad. What if I do like increase this to like 10? Does that smooth it? I think it kind of does a little bit. I think I'm just getting to max speed very quickly now. Okay, let's keep these kind of ratios kind of high. So like, let's put this to like 5, this to like 10, and this to like 1. That'll let me slow this down. Okay, so this absolutely has to be interesting. So let's go to like 1.5. Okay. So how does that come into play here? It's real squirrely when I increase that, but it is more smooth. So that's good to know. Okay. So I think a KP around 10 is absolutely required here. It looks pretty good except the little zag. Let's go back to 1.5. I think this was our best tuning. It just looks a little bit choppy. Maybe I'm imagining it. Maybe she's not choppy. I don't know. What are your thoughts? I guess let me check my speed here. I guess that would tell me. If I just print my speed, it should tell me how choppy she is. Print. Error, sure, but let me print my speed here. Do I just print my... Oh, I guess I could print my velocity. The end here. Print character.velocity. And what? If I want it to resist change in motion, right? Would I have... I should subtract by the change in speed instead of adding it. I guess I'm not using change in speed anymore. So maybe that that also helps. It's a little hard to tell. I feel like it's still choppy. But I don't know if that's just because I'm used to seeing it choppy. So I have this DT error. Let me think real quick. So this is a change in error, which I actually don't think is doing too much. Let me change this to DT speed and then subtract this. I think that'll let me tune down and tune out, like essentially resist the change in speed, because then as the speed, let me think real quick. As there's a larger change in speed, I'll slow down, which maybe isn't what I want. I gotta think that through. Maybe I do have to add it. So that if I have a larger change in speed, let's see. So there, if I make like a higher number, I think what's gonna happen is I'm going to slow down. Oh yeah. I mean, that is absolutely one way to get there. But squirrely is okay because that means I just have a parameter to control. Okay. Okay, we're getting there. That looked a little bit more smooth. Okay, that's pretty close. Let's try 0.9 here. Okay, she keeps trying to turn a little bit, so I need to resist that a little bit. So maybe it was like a 0.7. That was best. I mean, it's smooth in that direction. Whenever I'm turning the corner, not so smooth. But I guess I could turn up the max tolerance a little bit. Or I would turn this up a little bit. Okay, she's not. Okay. She's trying to kind of zag up there a little bit, but not too bad. Let's see what happens if I... Okay, short looks good. That looks decent. Straight line looks great. I think this looks pretty good. Here's what I'm gonna do. I'm gonna turn my movement speed on her up really, really high. And then just have her run really far. We'll see what happens. All right. So first, let me just run over here. Oops. That gave me nothing. Oh man, I have all of them tuned to 0. Oops. Okay, we'll try this again. Very good. Okay. So let me just see if I run like over here, how smooth it looks from the top down. Yeah, it's not bad. Okay. What about from like the front? It gets a little tiny bit squirrely at the end, but I think I may be able to fix that. Yeah, that's really not too bad. And the jumping is not great yet. Yeah, that's pretty smooth, I would say. Not bad at all, actually. I'm pretty happy with that. Let's see here. I mean, pretty consistent speed. Good enough for now. And I have the control parameters where I can do some more tuning later if I need to, but what would I change? Okay. Let me check just a couple little configurations here. Ultimately, I think that's pretty good. I will now add in the stop animation. Okay, she did get a little squirrely there. Let me turn that down just a hair. That's gonna be, let me think. It's gonna be here. Let's see if that helps. Yeah, she still is a little bit squirrely. Let's turn this down a little more. It will be keyboard compatible. Right now I'm doing just controller because, you know, I'm trying to pick one to develop in. But I will make it like, you know, you could use mouse and keyboard. I will say I'm 100% focusing on the like control using the keyboard, right, or the mouse or the controller. So it just feels really good. So, yeah, I'll have to play with it a little bit, but I think for the most part, I'll develop with a controller, and then I will add capability to be mouse keyboard compatible. The only reason I'm thinking that is like, it absolutely feels really good with a controller. It's gonna take time to add the same like feeling with a mouse and keyboard. I'm sure it's not gonna be impossible. You know, I'd replace the directional buttons with arrow keys. That's not bad. Or, you know, just like you get native, like I have some mouse controls, like I can click move, right? I can't click a square right now. I used to have it, but I took it out because it was taking up a lot of time trying to keep all of them up to speed. So yeah, ultimately, yeah, it's pretty good. I may also be able to change acceleration actually and max speed. I wonder if that impacts this too. So yes, I will be mouse compatible or keyboard compatible. Like that looks pretty decent. I don't know why I'm kind of like jagging out of the way of something. Let me see if I can extend that a little bit and see why that's the case. Turn this up. So yeah, I think it's that. Okay, I think it's this parameter. Let's see. So if I set that to 0, I think in this case I would. I'm not stop. Oh, I am stopping every square. Yeah, I'm stopping every square, but do I jag out of the way? I don't. So it absolutely has to do with this parameter. I wonder if there's just like a better value I can. Let's see. Okay, right there, I don't do it. That's great. Are you more of a keyboard gamer or more of a controller gamer? I think she's already starting to kind of jag out of the way. Yeah, I don't know why she does that. And maybe it's not a big deal. Is it super noticeable what I'm talking about? Maybe it's not a big deal. What if I set this to like 10? Does it resist some of that tendency to... Oh yeah, she's just everywhere. I forgot about that. Okay. More of a keyboard guy in Rainbow Six Siege. Okay, I got you. That's pretty smooth. I mean, there's like some small jags out of the way, but I think that looks pretty good. Oh, that's pretty clean. Okay, I'm gonna leave it at that. So these are my parameter values. Now I have to set them. Be constants. So what I'll do is I'll just take these and I'll change them from this. I'll say equals KP is 10, 0.7, and 2. My max tolerance is 0.2 here. And I'm gonna make these constants. Can't do FPS on controllers. Yeah, I hear you. I like doing pretty much everything on controllers. I just grew up with controllers, I think. I try, like, there's some games that I try to play with mouse and keyboard, and ultimately, like, I play with mouse and keyboard for a while and then end up doing controllers. I actually tried doing Final Fantasy Tactics with mouse and keyboard for a little bit, and it was just really, really hard. I mean, it wasn't designed for it, obviously. Just because it feels a lot more natural, right? To just kind of sit back. Oops. That one can stay. Actually, yeah, let's make that a constant too. My acceleration. But I'm going to make it 0.5. Match that. Okay. So yeah, it's hard. Like, even when I play like Civilization, right? I always defer to going to a keyboard. So I'm sorry, not to a keyboard, to a controller. I think it's just way better. Yeah, I agree, Loki. It's that's how I am. Like, there's a very specific game where mouse and keyboard makes sense, I'll do it. Like, if I try playing Diablo, though, if I try playing Civilization, all of that, I end up going controller, though. Hey, how's it going? I think that's Potato Gamer, right? Is that your alt? How's it going? See, I pay attention. Yep. Can't get one by me. Oh, very cool. Very nice. Oh, very awesome. Good to see you. We were tuning a PID controller. Just got it tuned. We were talking through kind of controls. And yeah, ultimately, I think it looks pretty good. Made some adjustments. I will say it's not perfect. I refactored all the code because it was getting to the point where like I was running under walls. Everything was like time based. I got rid of all the while statements, and now it's just like a PID controller, and it's so much better. Hey, I really appreciate you stopping by. Yeah, we're about to finish up here. I'm gonna add a couple animations real quick, I think, to stop on the right thing. Yeah, refactor. I need a refactor emote, I think. I say that enough. So this is my new code, right? So now I say, hey, go set what state you're in. I do need this back, but I'll add that back in a second. Go set what state you're in, and then go run that state, right? And it runs this every time. I got rid of a lot of while loops. I still have these while loops. I may end up getting rid of them. I absolutely despise while loops, to be honest. It's like this says like a dead man stop for half a second while I start running my jump animation, which it's not even doing. So yeah, I have some work to do here, and maybe I can just not worry about how fast I'm going and just do this, and we'll see if that fixes it. And then essentially this was my old code. My old code was like 100 while loops, embedded while loops, a bunch of different if statements. It was really complicated. This is much simpler. I still have, like, I haven't touched the jumping yet. I just copied it over basically. This went from, so right here running, this is my running state, right? Pretty simple. That replaced all of this. So that one line replaced all of these lines. I of course have a function down here, that's my PID controller, but it's so much simpler. So I replaced like 10 lines with a function that is 10 lines, that might be 20. 88 to 212, almost 20. Oh, it is 20, it's 23. With like 15, 16, but it's so much easier to control and a lot easier to look at. So, and what it did is it allowed me to not have a bunch of weights. In this, I just had so many like weights and waiting if you're on the ground and calculating a bunch of things. This is just so much simpler. So, feel good about that. I do want to add in my stopping mechanism, which is this. And I think that's going to be pretty easy. I think it's just this. And I have it doing world grid map over 2. I may here say max. Let's see. Ultimately, I think I stop on the last stretch. I kind of slow down. Okay, so I might just do max tolerance on this one every time. Let's see how that looks. So essentially it's going to look, and I need this else back. And it's only if movement nodes that size is 1, so I shouldn't be doing it any other time, but I feel like it's going to. I feel like my character is going to kind of be tweaking out. We'll see. Yeah, my character's for sure tweaking out. So you can see, right? Just kind of like sliding along, which is kind of funny. I mean, it's not bad. Why is that? Oh, I see why. I just missed a parenthesis. Essentially, I was just doing, hey, this and this, or just this. You gotta get your logic right. That should help and allow me not to do that. All right. Let's see. Hey, that looks pretty decent. Okay. Let's see. Yeah. Hey, I like that. Okay. Yeah, I think that's pretty good. Let's see what happens when I jump. I mean, she looks very aggressive while running, which is great, right? I mean, you kind of want an aggressive looking character while running here. Like, I think that's pretty good. The jump's not great, but I still need to work on that, but I like the little slide, right? Let's run onto here. That's a long slide. I probably can turn that down a little bit. I think essentially I can just divide this max tolerance by... Wait, what if I do min tolerance? Let's see. I'll slide a lot less, but that might be okay. Yeah, I think that's pretty good. Not too bad. All right, let me look at this one more time just to make sure. I think this statement here, it's movement tolerance. What's my movement tolerance on here? Min max movement tolerance is just is nothing. Interesting. Wonder what's set to. I guess I can check. Huh. Oh, it's not exported. Where do I set it? Movement tolerance. Okay, so I dynamically change it there. Okay, that's fair. That's fair. That's not bad. Okay, I can leave that. And then if I'm within min tolerance, maybe I could do movement tolerance. Well, movement tolerance will always be min tolerance there. So I think if that's always min tolerance, I think I can get rid of this. And basically just say, oh, you know what? Actually, I could flip this and instead say, hey, if the distance between where I'm going and where my character is less than max tolerance, so if either of them are less than max tolerance, no, I can't do that. I have to do and. If they're both less than max tolerance, then I should slide. And that might look pretty good. Let's find out. Now we're just tweaking a little bit. Did resolve some good bugs though today. I think the movement bugs were a lot of what I was seeing. I probably still have them on the enemies. We'll find out here in a second, actually. That looks less good. I kind of like the slide, I think, a little better. Right? What if I just do like 0.5 here? Let's see. Oh yeah, that's the key there. I think that looks good. Let me know your thoughts. I don't know if that was better or if it was better before. Yeah, maybe not. Maybe it was better before. What if it is less than 1? So I like the kind of little slide, right? Where she's kind of sliding into it. And here she's definitely stopping on it, which is okay, I guess. Let's see. Yeah, I think the slide looks great. I think that's what I need to do. Yeah, that looks good. Okay. Pretty good. We'll see if the enemy moves decently. Yeah. Yeah, not bad, not bad. I think we fixed it. No new bugs. Okay, she definitely has an unfair advantage here. That's pretty good. I think that looks fantastic, honestly. Okay, I need to cast before they move. Honestly, game's getting a little bit fun. Oh. Okay. Well, he's trying. I didn't expect that. Essentially, he's not building up enough speed to make it over that wall. He's getting stuck under it. Oh, okay. We'll have to deal with that bug next time. That's unfortunate. Okay. I might just turn off collisions for a second when you're in the air. Oh, interesting. Yeah, that looks, the running honestly though looks really good. It's the jumping that I really haven't touched. So I need to refactor that code. If I get a running start, I can make it. I shouldn't need a running start though. All right. I think I'm about to call it a night though. Yeah, I've got to fix that animation. Actually, before I go, I think gonna fix that one. That one I think is super easy. I have to be passing the wrong node here. You know, I say that, but I think last time I said that I ended up streaming for like another hour, so I don't want to do that. Party list. Let me look down here. When I build this, I should build target cell. And so I pass magic cast over there. And then so my camera, when I cast a spell, magic here. So that goes to follow target. Is that really what I want to do? Maybe target grid. Do I set target grid here? Yeah, target grid equals magic.target cell. Okay, maybe. Do I set it anywhere else? Okay. Interesting. Anyway, we'll have to deal with that one later. Probably gonna go ahead and find someone to raid. Sign off for the night. Okay, so list of to-dos then. Let's pull those up. Okay. Oh man. Why is, let's see, pulling the wrong thing here. Let's see why it would do that. Guess I can do that. And it did pull my Trello. Pretty strange, I would say. It's like it's named wrong. There we go. Anyway, don't know what that was about. Okay. So, I had some bugs. When casting, target doesn't, target cell isn't scrolled to, I guess. Moved to. For some reason, it used to. I have a feeling actually that I know what that is. I may try one thing because it just hit me what that might be. And we're gonna be working on that next time. I think that's my main one. And then jumping is broken if standing next to ledge. I'll work on that one next time. Oop. I gotta get some stuff off this bug list. Let's see, did I complete any here? That one's been resolved. Okay. I already have characters not jumping consistently. Some of that's resolved. Okay, let me check this real quick. I just realized here in target cell, I think I'm passing along cell information, but I don't know that I'm actually passing along the like the grid cell or the actual position, if that makes sense. So essentially when my camera moves over there, right, I think I have to divide by world.grid map size to convert it into my grid map domain. Let's try that real quick. All right, let me get rid of my Trello. Let's see what happens here. I didn't used to have that though, but I could have just been testing it in a location that's near 0 or something. Okay, that actually looks pretty decent. Let's go over here. Okay. Oh, nope. It went back to that same location. Okay, so that's not it. I'll come back to it. Anyway, all right. I think that pretty much is what we're going to be working on next time. Keep resolving bugs. In the meantime, I'll probably see if I can. A couple things I need to do still. I need to create more characters up here. I need to build a demo level, and I need to build some cutscenes. I may work some of that offline. We'll see what I do. And I need to build magic animations. I'll at least build the first magic animation offline just to get the process down. So we'll go from there. All right, with that, let's go ahead and get ready here. Let's find someone to raid. And we'll call it a night. Thanks everybody for hanging out. We'll catch you next time. I should be streaming again tomorrow. If I not, I will let you know in the Discord. So if you're not in the Discord, check that out. Thanks everybody.